Hi everyone. In today's video, we are going to discuss how to use inbuilt machine learning models in a OAS data flow. So for this demo, I have already imported a donation related data set, as you can see on my screen. This is the data set that I'm going to use as a source in my data flow. So let's go to data flow tab, create data flow. I'm selecting donation data set. And what I'm going to do is to test my ML model, I'm going to select only 15% of data in this donation data set. So I'm going to create a custom column here by clicking on add column. Let me give random as a name here. Function, let me validate, click apply. Then I'm going to save this data set. And between add columns and save data, I'm going to apply my filter. So I'm going to apply a filter on this newly created custom column. I'm giving the value as 0.15, that is 15% of the data set. And I'm saving it as yes_ml. Okay, so this data flow is saved. I need to run this data flow. Okay, now this data flow is complete. So let's see whether the data set is created. Let me refresh the same. Okay, so I think because I did not rename it, this got renamed as new data set. That should be fine. So instead of instead of taking that ds_ml, I will take this new data set as a input for my remaining data flow. So it is important to understand what we have done so far. So let's say I had a donation related data set with 100 records in it. What I have done using a data flow is I have filtered out only 15% of the records from it. Now whatever this new data set one that you see on my screen here, this will act as an input to my machine learning model. So I'm creating another data flow and I'm selecting this new data set one as the input. And I'm clicking on select columns just to ensure that this random column is not unnecessarily picked up. So I'm selecting all the columns that were there initially in my data set. And now I'm going to select the appropriate machine learning model. So it is very important to understand what model to select here, and it is subject to what sort of prediction you are trying to do. So if you are trying to do any numerical prediction, like in our case, we are trying to predict total donations, because it is a numeric value, we will select train numeric prediction. If you are trying to do a prediction where the output is binary in the sense it will be always between 0, 1, yes or no, then you take train binary classifier. If it is still a classifier but values are more than 2, then you select train multi-classifier. And if you are trying to do some sort of clustering, then select train clustering. So for this demo, I'm selecting train numeric prediction. There are four options, four different models available with me. Random forest, linear regression, elastic net linear regression, and cart. So for this demo, let me select two of it. Let me select elastic net linear regression, for example. I'm going to select the target column that I'm going to predict. So it is total donations. There are a lot of input parameters or properties here that you can toggle and change to get better accuracy. For now, I'm going to keep them as it is. Save model, I'm going to rename ds_enl. So this is where I had to give the name which I forgot in my earlier data flow. That is why it got created as new dataset one. So now I'm renaming it as ds_enl, and I'm selecting the data flow name as df_enl. So enl is nothing but my elastic net linear regression model that I have picked up. Okay, let me confirm whether it is the same. Okay, elastic net linear regression. I'm saving it. And now I'm running this data flow. Oh, okay. Now this data flow is done. Let me go back. Let me go to machine learning tab. And if you see here, there is a machine learning model with ds_enl. Now let's inspect this data model, click on quality. Now you will see a lot of values here. I do not want to go into details of what each value signifies because I'm going to cover it all in a separate session. But just to explain you in a nutshell here, you need to go through each value and see what the value represents. So ideal recommended value will be should be they should be as low as possible. Your mean absolute error, median absolute error, root mean square error, they should be as low as possible, and relative absolute error RAE and RSE should be as close to zero as possible. So it is always recommended that they should have a value between 0 to 1. The value should not exceed more than 1, but they should be as close to zero as possible. So using elastic net linear regression, we have got a value of 0.82. Now let's try out another machine learning model using a different data flow. So I'm again going to select the same data set. I'm going to remove that unwanted column that we used for filtering the data. And I'm going to use numeric prediction, but this time I'm going to use my card for numeric prediction training model. So let's select total donations, and I'm saving the data set as ds underscore cart. Let me save the data flow as df underscore cart. Click OK and run this data flow. All right. Once the data flow is done, you will see that there is a machine learning model for cart that is created just like it was for elastic net learning. Now let's inspect this model to see what is the quality and how the values are stacked up. So as you can see here, the key one that I am looking right now is relative absolute error, which was 0.82 in case of ENL, and it is 0.63 in case of CART. So like this, you can apply different machine learning model to your data set to get these values. Now what I'm going to do is I'm going to use these two ML models to see how closer the values are to the actual values that we had in our data set. So I'm going to my data to data set, and I'm going to create a workbook on top of the donation dataset that had all the values, which is our master dataset basically. Then I'm going to select two columns, total donations and date posted. I'm going to create a visualization on top of it. Okay, so there are a lot of values here. What I'm going to do is I'm going to apply a filter. So let's apply a filter based on year and month. So let me just okay, so it's reverse. So let me just select 2014 and let me just select last 3 months of we had data for. So this graph actually shows the total donations that are posted for the month of June, July, August 2014. Now let me import my machine learning model. So create a scenario. I'm going to import elastic net learning, elastic net linear regression. And as you can see, the prediction value is available here. So now let me just drag it here into y-axis. What it will show is it will show how closer my prediction values are to the actual values we had in our data set. Okay. So looks much closer for most of the duration, but let's import another one for which we had 0.63 as RAE. And let me drag it here into y-axis. As you can see now, the values that cart predicted are much closer to the actual values that we had in our original data set. That is what this graph is telling us. Now let me just duplicate this visualization, and I'm going to check these values in a table. All right. So as you can see here, my total donations for 1st of January 2014 were 48,188.21. This is the actual value that we had in our data set. But what I will do is, so of these two, let me remove the one that was there for ENL, and I'll only keep the cart value. So let me total donation prediction and total donations. Fine. So this is my actual value, total donation, and I'm going to select the one that my cart model predicted, because we already know that the values given by cart model are more accurate than ENL. Okay, so this is what my prediction looks like. Now let me find out a percentage. I'm adding a calculation here. So just giving any dummy columns. So we take the prediction value divided by the actual donation value, total donations, and click save. Okay, I'm just dragging this column into my rows now. So this is I'm doing to find out what is the average accuracy of my cart model. So okay, now let me go to percentage. Is there an option? Okay, go to properties, grand total on. All right, so it is giving me the accuracy of my prediction. What is my cart predicted versus what is my actual prediction. So of these also, what I'm going to do is, let's see if there's an option to filter these out. I'm going to apply this filter here, and I'm keeping maximum as 1. Okay, so there is some syntax error. Let me modify the filter. Okay, so it is not taking this value. So let me remove this filter. And let me take it at the top. We start with 0.1 and 0.99. Okay, so it is not allowing this filter over here. So let me delete this filter and let me keep the values as it is. What I will do is, let me see if it allows me to create a custom filter. It will not allow me to create a custom filter because it is created on this machine learning model. So fine. What I'm trying to show you here is what is the overall relative accuracy of my cart model. So if you see here, you can ignore the total donations in the first two columns, but what is important for you to see is the accuracy of the model, and this is the average accuracy. So you will realize that more sometimes the total donation predicted by the model are higher than the actual ones, but sometimes it is very close. Like for example, for 3rd of June 2014, the accuracy is 97%. So if I see the average accuracy of the cart model, it is 92%, which is very good because we have not done any fine tuning of the model. We have used the model as it is with the default parameters. If you keep on fine tuning the parameters, you might see that this accuracy could go higher. But in its original form, the cart model is giving us a 92% accuracy for the donation data set that we have. So the next step here would be, now you have figured out, okay, of all the four models that are available with me, cart model is the one which is giving the highest accuracy. So you can use that model to predict donations that could happen going forward. So this is how you can test the model, train the model, select which model is relatively accurate for you, and take that model and train it going forward. I hope you have enjoyed this small session on how to use inbuilt machine learning models in OAS data flow. If you have any questions, please drop them in the comment section. Thank you so much.